Okay, in this video we've been given a 10 kg block and it rests on some surface, and you've been given the coefficient of static friction, which is 0.4, and the coefficient of kinetic friction, which is 0.35. The question is find the range for the static friction and also find the kinetic friction. Okay, so once again, if you remember from the previous video, the range for static friction, it simply means that the static friction changes from, ranges between two values. What we know about the static friction is it goes all the way from 0 to some Fs max. Okay, so to find the range, we just need to find Fs max, and then that will give us the range. Now, Fs comma max, which is the maximum force of static friction, is equal to mu s times Fn. So before we do anything, we need to calculate the Fn for the object. Okay, if you look at the free body diagram for the object, what we have is we have a force of 98 newtons pointing down, and then we have the force of contact, which happens to be Fn pushing up. And since the object is not accelerating vertically, what we know is that Fn is equal to 98 newtons. So what we have is we can substitute for Fn in this equation. We get 0.4 multiplied by 98, and that gives us the value of 39.2 newtons. So the range for static friction is that the static friction ranges from 0 all the way to 39.2 newtons. So that is our range. We're now ready to calculate the force of kinetic friction, which is simply equal to mu k times Fn. And since the coefficient of kinetic friction is already given, it's 0.35 times 98. Okay, we can obtain this value as well. And it is a value of 34.3 newtons. So this completes the problem. Okay, so in this problem, all we did was we just calculated the values, the ranges, and all those things. All right, in the next one, we'll explore more about, whether an object will move or not.